Welcome to FMA 0116 Mathematics 1. In this video, we're going to discuss determinant of matrices. The size of the matrix cover here is 2 by 2 and 3 by 3 only. And we are going to discuss some of the properties of the determinant. First of all, we look at the properties of the determinant to ensure that you have or the other way around, only the square matrices will give you the determinant. And over here, the K over here is a scalar. Okay, if you want to find the determinant of a scalar multiple with a matrix, so actually you can finding the determinant of your matrices, the matrix A, but if your scalar will be power to how many what is the size of your matrix? Okay, if you have the square matrix of 3 by 3, so your n is 3. If your matrix is 2 by 2, so your n is 2. Okay, if we want to find the determinant of the multiplying of A and B, so you can finding the determinant of A and then you finding the determinant of your B, then you multiple both of the value. And the best part of the A transpose is if you want to find the determinant of your A transpose, actually it will be the same value as the determinant of your A only. Okay, so let us look at the example. Let us have a matrix A, B, C, D, E, F, G, H, I, and the determinant, let's say we have the P. So when we look at our matrix W here, actually every element is multiplying by -2. So that means each of the element is multiplying by the scalar of -2. So when we factor out the -2 from each of the element, so means that we are actually this is the size 3 times 3. So we're going to have the power of 3 and the scalar is -2. So we're going to have -8. And the determinant of our A actually is P. So means that our determinant of the W actually is the -2 power of 3 and the determinant of A. Okay, now how about C? C actually is A transpose. If you see that ADG is from the first column. B, E, H actually are for the second column. Okay. And from the definition before here, we already said that the determinant for the A transpose is same as the determinant of A. So that means is the determinant of our C is equals to P. Okay. Now we look back to our matrices of matrix B. Okay. Now what is the difference B and A? The difference will be my second row is the whole row been multiplying by 2. My third row is all multiplying by 3. So actually the determinant of my B, okay, so the determinant of my B can be from the 2 times 3 and finding the determinant of my A. So it will be negative 6p. Okay. So what is the difference between A and between the W and B? The W is every each single one is multiplying by our -2. So actually the W is negative. Okay, W actually is negative 2a. But the thing is, our B is not the negative 6a. Okay, remember, it's only one row and one row. So when you take out any single row, so you just multiplying by the value to find the determinant. Okay, now if you have the two rows or two columns are interchanged, okay, and there's only the sign of the determinant are changed. Okay, so let's say I interchange the D and H row 2 interchange with row 3 or the our row column 1 is interchange with our column 3. So our determinant of our D is we will get the different sign. What if let's say now row 2 become row 3, row 3 become row 2. How about my row 1 is interchange with my row 2? So that means the sign is going to change again. That's all. Not it means that it depends on how many times you interchange. One times change, you have the different negative. One more sign change. Okay. Then we look at the number 5. If two rows or columns identical, the value of the determinant is 0. Okay. So if we look at it, row 2 and row 3 are same, and column 2 and the column 3 are the same. So means that the both determinant are 0. So this one you really learn during your secondary school. How to find the determinant of 2 by 2? So we have the A times D minus B times C. Okay, now when we want to go for the determinant of 3 by 3, before we going into determinant, so first thing you've been introduced the minor and cofactor. And as we said before, to ensure have a determinant, that is you must have a square matrix. Okay, now the minor of the square matrix, okay, sorry, the minor of my matrix A is denoted by Mij, okay. So how to get the minor of Aij at Aij? How you want to find? So it said that deleting the I row and the j column. Okay, how to find A11? It means by A11 means that you delete your row 1, you delete your column 1. Okay, so let's look at it. M11. So we're going to have M11. So we delete we can say that it's covering our row 1 and column 1. So we find the determinant of EFHI. And then let's say you want to find the minor for your M23. So you are covering your row 2 and the column 3. So you're going to find the determinant of A, B, G, H. Okay, now, so basically, if you want to find the complete set of a minor matrix, means that you need to find 9 determinant of the each element. Okay, and then now you'll be introduced by the cofactor. What is the cofactor here? That is, the cofactor is only going to change your sign. Okay, either will be positive or negative. The value is not going to change. Okay, so let's say you have C11. So your I is 1, your J is 1. So you're going to have negative 1. 1 plus 1, M11. So negative 1 power of 2 actually is a 1. So you still have M11. So how about you want to have C23? C23 is negative 1. 2 plus 3, M23. So you're going to have negative M23. So basically, what we're going to have is the sign is alternating. Okay, the sign of the thing is alternating. So we start from the positive, negative, positive, negative, positive. The sign beside it, up, down, will be always the different sign. Okay. Now, so what we're going to have our cofactor? So you will have the original, your minor. Then you put the sign here alternatingly. Okay. Okay. This one I think is wrong. This one is the minus. Okay. Sorry. Okay. Now, look at the one example. A is 1, 2, 3, negative 1, 5, 7, 4, negative 2, 0. Okay, how to find M11? So you cover row 1, column 1. So you find the determinant of 5, 7, negative 2, 0. 1, 2. So you cover 1 and 2. So you have negative 1, 4, 7, 0. And you, okay, let's say 1, 3, another one try. So it's negative 1, 4, negative 2. And you repeated for the rest of the value. Okay, so next let us check. How about 3, 2? 3, 2 covered row 3, column 2. So we have a determinant of 1 and negative 1, 3, 7. And the last one will be 1, 2, negative 1, and 5. Okay, now, so after that, how you want to get the minor factor, minor matrix is 5. Okay, determinant 2 by 2 is 5 times 0. 5 times 0 minus 2 times 7. So this one is positive 14. Okay, so this is positive 13. So let us try this one. So you will have this one. So minus 2 minus 8. So you're going to have a minus 10. Okay, so this is called minor matrix. Now, how about cofactor? Nothing magic. Just put the sign here should be positive, negative. This one is positive, negative, positive, negative. positive, negative, and positive. So negative, negative will give you 10. So this one positive, negative will give you negative. So this is negative 10. Okay. Now we look at the determinant of a 3 by 3 using cofactor. Okay, this one you have many choices. Either you use the whole row, row 1, row 3, either. Okay, choose one. Or you can use column. Okay, so let us look at the first one. We choose the row 1 and matching back to our cofactor 1. Okay, so cofactor for our row 1. So how you find the determinant? Take the first element, multiple with the first element. Second element multiple with the second element. The sign, the operation here all are plus. So your final answer is 16. How about if you choose by using the first column and the first column of your cofactor? So you will getting so the same thing. The first element multiple with the first element, the second element multiple with the second element. Okay, so you will get the 16 also. Okay. Now, how about we have the another one is called determinant of the matrix 3 times 3 using diagonal expansion. What you need to do is the same matrix, but now you add extra two column. Okay, where these two column coming from? The first one put at the as your fourth column. The second column put as your fifth column. Okay, after that, now what you do is okay, what you do now is okay, before I erase it first. Okay, then from the leftmost going down, strictly diagonally going down, and then you use multiplication. 1 times 5 times 0 actually is 0, and you do 2 times 7 times 4, and then the last one is 3 times negative 1 times negative 2. This is the one in blue color. And the same time, don't forget to do the other way, is going up here. 0 times negative 1 times 2, and negative 2 times 7 and times 1 is negative 14, and 4 times 5 times 3 actually is 60. So now actually here you can see that this is producing your red color, this one is producing the blue color. The how to find the determinant is the sum of all the blue minus the sum of all the red one. So you're going to have a 56 plus 6 is 62 minus 60 minus 14 actually is 46. So you get your 16. So regardless you are using the expansion of matrices or you're using the adjoint, you will get you the same value of 16. Okay, thank you. See you in next video.